Hi, today I'm going to show you something which is not very practical, but when studying or during an interview it might be handy to know this. So, the main theme of this video is checking whether a number is a prime or not. Considering this is not very hard task to do, we can go with TDD approach, so test-driven development. Right here I want to just stress out that if we wanted to make it look more professional or better in general, we should probably make another folder with tests and introduce PyTest or at least unit tests, but I'm going to use plain asserts. Let's define our function for testing. It's gonna be called runTests. It's gonna take a single parameter, test data. Test data is going to be a list of tuples with integers and booleans inside, so actually when looping over that, it's gonna yield us the number and the expected result. Here I'm using the walrus operator to assign the outcome of the isPrime function to the result. If you are using Python before 3.8, it's not gonna work, so you have to find another way to do it, but it's quite convenient in here. And let's define the stub of our function. It's gonna be called isPrime, gonna take a single integer number and return a boolean value. Right now let's hardcode it and return false. If our assertion fails, let's raise an assertion error with a string saying that for a particular number the expected was this and the actual result is this. Alright, now we have to invoke our function, but actually it would be more convenient if we didn't hardcode isPrime in the body of that function. Rather, let's take a second parameter, call it function, and it's gonna be a callable, so we can pass the function we want to test into our runTests function. And now let's define some test data. So it's gonna be a list, as I mentioned, of tuples. Let's say 1 and false, or maybe 2 and true. Right now would be better because we are returning false, so this should trigger the assertion error. Let's check. Okay, that's fine. We got the assertion error as we wanted, so the testing looks fine-ish, let's say. Let's define some more examples. For 3, let's return true, and let's expect true actually. For 5, or maybe for 4, let's expect false. And for 1, also let's expect false. And maybe something bigger, for 99, let's expect false as well. We also want to know if the tests passed, so if no assertion error is raised, let's print out that for number the test passed. So now let's jump to our isPrime logic. So if the number is in the set of 0 and 1, we want to just short circuit and return false because neither 0 nor 1 is prime. If it's equal to 2, let's just return true. If it's equal to 3, let's... No, I'm just kidding. Like, you know, if we want to check like infinitely more numbers, it's going to take too much time. So let's figure something out. Let's start from I equal 2 and let's use a loop. So we want to loop until I is smaller than our number. And in the loop, what we want to do is we want to divide our number by I, and if the remainder is 0, we want to return false, because obviously the I is another divisor of number, so it's not prime. Otherwise, we want to return true. And what we need to do is we need to increment I by 1. Okay. Seems okay, so let's give it a try. The test passed. Nice. Okay, so now just out of pure curiosity, let's check how long does it take to invoke this function on some bigger input. So timeit is gonna actually take a callable, so let's use lambda in here, and we'll define a list comprehension, and we'll use the number of, I guess, about 1000 tries, and we're gonna check also numbers in range from 0 to let's say 1000 without 1000. Now let's just assign the result to a variable. And let's print it to the output with some formatting, like 2 decimal places should be fine. .11 seconds. Okay, I got like no other results to compare to, so no idea whether this is good or bad, but let's take a look at our function and maybe we can like improve it somehow. So first let's copy paste it just below, and let's call it isPrime optimized maybe. First, what we want to do is we want to run the tests for our optimized version as well, so we want to make sure that we don't break the logic when optimizing, let's say, and we want to time it as well, so let's copy paste this one. Let's take a look at our isPrime optimized. So basically 2 is the only even number which is prime, so if the number we are checking is divisible by 2, we should return false. Okay, let's check whether that improved things. Well, this doesn't look too good, to be honest. I was expecting something different. Let's try again. Nope, something obviously isn't right. Okay, so it looks like the functions work better when they are actually invoked, so when copy-pasting I just didn't change the name of the function being invoked in the second timeit. So let's give it a try once again. Let's just clear the output first. Oh yeah, now it's a great outcome. No, but seriously, it can be like a discrepancy between measurements and so on, so that doesn't seem to help too much, but let's take a look what else can we do. So actually we can start from 3 and we can like increment I by 2, so we can check only the odd numbers. Let's just comment out the tests for now because they are like giving too much output. Okay, now it looks better. It looks like it makes some difference at least. But there is a second thing. So actually we don't have to check whether I is smaller than number. We can check if the I squared is smaller than number. Because if you think about it, if I is a divisor of n, then n divided by I is a divisor as well. And this looks even more impressive. This time we changed the complexity actually. Before we've had like the linear complexity, and right now we've got the complexity of square of x, where x is the number we are testing. Alright guys, I think here it's gonna be like cut probably, because I invoked it with too big range, so it's gonna take too much time. One more comment is, if you've been wondering whether you can use something like a map in that lambda instead of that list comprehension, then I would say not really, because map is lazy and the only thing you are gonna test that way is the time needed to actually allocate the map object, which is a generator in the memory, so that's gonna be like instantaneous, so that doesn't make too much sense. And I guess that's it for now. Thanks and take care. Bye.